Hey everyone. Thanks for introducing. And so VLM calibration is a project that we've been working on for a while. And initially we've been working on the LLM side of things, and we would like to like move on to VLM very soon, as the LLM project is wrapping up. But we have some interesting updates for that. So the motivation of calibration is to basically kind of understand whether the LLMs are trustable or not, whether they're reliable or not, because like there are often times where we can just accept whatever they say for like, and that's like not the best way to go about things as we keep trusting and trusting these things more, and these things are more integrated in our day-to-day lives. And from LLMs, these problems kind of compound when we move on to VLMs or like more agentic approaches where they are doing more and more of the work, and we just trust them to do all of the work right in the right way, but we don't really know what their motivation is or like what their accuracy is at each step. They might be right, but they might be thinking that they're wrong, and that might like affect the next step. So we have a very broad set of experiments for figuring out like what to do with regard to this and like how to verify this. We kind of try to ask them whether uh, like looking at them whether they have like a confidence score that they can give, or we can try to look at the logits, which kind of can try to figure out we can try to figure out like how probable they are in their outcome, like they're outputting some option, how probable it is. And we conduct experiments across like various model families and various model scales to figure out what is the thing that's actually driving this. Can this be a problem that can be just fixed by scale? Is reinforcement learning causing some problems with respect to the base model, in the sense of like making things more overconfident? Because we train these models through RLHF, but we all humans kind of prefer models to kind of accept whatever they're saying. So in a sycophantic kind of approach, that's kind of some factor that might drive this overconfidence. So we have an interesting set of results. Sid, if you move on to the next slide. Yeah. So a lot of the times in literature, as well as like while working in real world applications, we tend to ask LLMs for confidence values, like, okay, like classify this, and what's your confidence of classification in 0 to 1 scale. And that turns out to be very useless in current models. Uh, there's literature explaining that this was something that was viable during Claude 2 and GPT 3.5. But right now, with current models, LLaMA 3.1, Qwen, Gemma, these seem kind of useless. Scale matters, but like every model kind of has their own different kind of approach. Every model family has their different kind of scaling with respect to scale. So, for example, some model might be very overconfident on GSM 8K as they move like upwards in scale, whereas some models might be like very less confident in real world knowledge, like simple QA. And this we've observed like different behaviors in calibration over LLaMA, Qwen, and like even over different data sets. We have like a very comprehensive set of results that we are willing to kind of compile and publish very soon, I think. And yeah, every model kind of has their own different response with respect to chain of thought. So asking them to think about whether their response is right or not, uh, every model at various scales has different kinds of responses. Some tend to back off, some tend to double down. And uh, like we have designed like various scenarios that kind of enhance these effects more. Model family keeps mattering. Like, for example, we saw the previous slides where Gemma, where LLaMA was moderately well calibrated, not very well, but Gemma as always, and Qwen, like we've talked about in our previous research updates, keep remaining very overconfident in most cases, like in MedMCQA, which is probably not the best thing considering the fact that these are medical data sets or medical question and answers. Another thing that we've found is like given the model's own text, but saying that they're from another AI, the model's still confident enough, but asking the same question when given another model's answer, the model is very pessimistic. And this confirms the fact that we've seen in some other research papers going in like similar directions that models can kind of recognize their own text, but given the same answer from a different model, they're not very confident. And chain of thought often shows doubling down on their own text, but is very pessimistic on the other models' thoughts or ideas. Uh, to kind of dive deeper into these experiments, we use OLMo, which is we have their training data, which is very publicly available, and we also have this way of n-gram matching over their whole data set, the pre-training and the post-training data set. So we kind of try to figure out how concepts or frequency of concepts in the data set might be related to some of these calibration tasks or like metacognition tasks. Uh, the thought would be that like if something is much more represented in the data set, the model might tend to be more overconfident on it if something is like overrepresented in some set. Uh, Initial experiments don't really show that, but they are still very brittle, and we're still working on refining some of these experiments. Uh, and yeah, so to make these experiments more like robust, we're thinking of using NER experiments instead of n-gram matching, and try to semantic search over the large corpus of data sets to figure out if those are some ways that would reveal, okay, these models might be over-calibrated because of concept matching instead of n-gram matching. And we slowly plan to scale towards VLMs as we expand the team. We've recently expanded the team a bit, and I think that's going to help with bandwidth and things like that. And yeah, uh, I think that's mostly it. If anyone has questions, be sure to let me know. Thanks.